As you were doing this one, finding the missing side there, again, the difference is you're finding the shorter side, so you're going to end up subtracting the area of the squares, right? You have the big square and one of the small squares. You need to subtract those areas. So you can start it off by writing your equation that way. You can write your equation as n squared equals 25 squared minus 10 squared. You could start this way, just maybe you find a couple extra steps in solving for the variable there. But the rest is, other than subtraction there, finding it the same way. All right. We're going to look at the second example. This is different. This is not finding a missing side. Okay. The previous thing was in a triangle, you know that it's a right triangle, and you know two of the sides, and it says find the missing side. That's what the previous example was. This example is not that. Okay, this is kind of changing it around a bit here. This is if you know all the sides, but you don't know whether it's a right angle or not there. So this is like question mark here. Is this a right triangle? If I gave you those four numbers, is that a right triangle? How could you check? How could you check whether this is a right angle here? What could you do? Add up the two. No, I wouldn't say add up the two legs. Add up this, right? Because if 3 plus 4 doesn't equal 5, right? The numbers themselves aren't going to add up. What's going to add up? Yeah, the areas. If you think about the areas of the squares on each of these, so it's not that 4 plus 3 is going to equal 5, because it doesn't. But you could check whether 4 squared plus 3 squared equals 5 squared, whether the areas on the sides of the squares on the sides equal. If this works out, which it does here, 16 and 9, 25. 25 equals 25. Those are equal. Therefore, this has to be a right angle. That's what's involved in this example here. This word verify here. What does the word verify mean? Check. Check. If you say verify something, check something. Verify that the doors are closed. If I ask you to go outside and verify that the doors are closed on the hallway to the outside, or verify that you have your book open to something. Verify means to check. Danelle is checking whether this is actually a right angle or not. Most of the the corners in your house are going to be right angles. They might not be exactly right angles, but they're going to be pretty close. She's checking whether it's a right angle by measuring a certain distance this way, and then measuring a certain distance that way. Can't really see that, can you? Measuring a certain distance that way, that's not much better. And that way, and then using that ruler to measure that distance. So this triangle here, she's checking to see whether it's a right triangle. She has that this is 30 and this is 30, and this is 41. She's measuring that that's 41. And so basically this is what she's checking. She's saying, is this a right angle here? If you work out the area of those three squares, okay, so she works out 30 squared is 900 plus 900, which is 1800. And then the right side, the other side, the big square, 41 squared is 1681. It's probably not even close to a right angle because these are quite different. They're not even close to each other. This is not a right triangle. So this conclusion comes from the fact that these two are not equal, right? The sum of the smaller squares doesn't equal the bigger square. Can you right now try this and check it? Okay? Check whether it's a right triangle. Put down some kind of logical. Okay, rectangular foundation, diagonal length. You have all three measurements, but you don't know whether this is a right angle. So to check it, you can check whether the Pythagorean relationship works or not. When you work out what 17 squared and 20 squared is, 289 plus 400, you get 689. Okay, that's the area of the squares on each of those sides. If you work out what, if you work out what the area of the big square is, it's this. 689.0625. It depends on your definition, because you could probably, say you're correct either way you argue here. It's not, if these are precise measurements, then it's not exactly a right triangle, but it's pretty close, right? It's very, very close to 90, even if it's not. Probably if you measured something that big, you couldn't measure it that accurately anyways, so you could assume it's a right angle. It's so close that it's, it's not exact, but it's pretty close. So you could say it's basically a right triangle because the two numbers are so close. Or you could say it's not exactly a right triangle, but it's very, very close, if you do that in your calculator. Is there any questions about this? Remember, you should look at the key ideas before you get going on things, or even afterwards. Okay, you can determine missing distances, and you can check if a triangle is a right triangle. If you look at the check your understanding questions here, don't forget to do that at some point. Whether you do the communicate the ideas before or after the check your understanding doesn't matter to me. In some ways, these are more difficult and involve sort of more thinking, so it might be useful to do those afterwards. But doing this using your learning guide, either doing most of you are doing the typical, but you need to talk to me if you're going to do something else. Okay? Everybody's okay then? Work on this. Don't forget you're putting it in your learning guide. Not your learning guide, this thing, your record sheet. I have not been writing too much down here, but you should be writing down. I'm assuming we're getting up to the point of 3.5. Check your understanding. You might have 3.5. You could put down that we went through the examples together. Okay, because you didn't go through them by yourself. Examples, and show, you can abbreviate it if you want, as a class. You can put that down there. 3.5, when you get to the end of 3.5, or as you're going, mark it and give yourself some kind of evaluation, right? You can put the check your understandings if you mark them using the back of the book or using these computers here to see the full solutions. You can put your quiz marks on here if you want. Whatever you want. I'm kind of thinking this is a collection of some of the things you've done, okay?